There is a raised bed modification that, in a peer-reviewed university study, produced 60 to 70% more food than a standard raised bed. Same soil mix, same fertilizer, same greenhouse. The only difference was where the water came from. And yet, if you search YouTube right now for the best raised bed designs, you will scroll past hundreds of videos before anyone even mentions it. You will find gorgeous tiered beds, elaborate keyhole gardens, and beautifully stacked hugelkultur mounds. All of them look incredible, and not a single one of those designs has ever been tested in a controlled study. The modification that actually has the science, it looks like a completely normal raised bed. You cannot even tell the difference from the outside. And that might be exactly why the gardening internet has been ignoring it for the past decade. Let me explain what it is, why it works at the biological level, and how you can build one in a single afternoon. The modification is called a wicking bed. The core idea is so simple, it almost sounds too good to be true. Instead of watering your plants from the top and hoping the moisture reaches the roots before it evaporates, you put a sealed reservoir of water underneath the soil, and you let the water rise up on its own through capillary action. Think about a paper towel touching the edge of a puddle. The water climbs upward through the fibers without any pump and without any pressure. That is capillary action, and it is the same force that pulls water from deep underground into the tallest redwood trees on Earth. A wicking bed puts that force to work inside a raised bed frame. At the bottom, you have a waterproof liner creating a sealed basin. Inside that basin sits about 8 inches of gravel or coarse aggregate, which holds the water reservoir. On top of the gravel goes a sheet of geotextile fabric to keep the soil from washing down into the stones. Above the fabric is about 12 inches of lightweight potting mix, where your plants actually grow. A PVC pipe runs from the surface down into the gravel layer so you can fill the reservoir from above, and an overflow drain set at the top of the gravel layer prevents waterlogging. That is the entire system. Water goes in through the pipe, fills the gravel reservoir, and rises upward through the soil by capillary action. Your plants drink from below, and the surface stays relatively dry. Now, I know what you might be thinking. How much difference can this actually make? This is where things get really interesting, because unlike almost every other raised bed modification floating around on the internet, this one has been put through a proper, controlled experiment. In 2016, researchers at the University of South Australia published a study in the journal Horticulturae comparing wicking beds against precision surface irrigation. They grew tomatoes in a greenhouse, used a randomized complete block design with multiple treatments and replicates, and measured everything: fruit weight, water consumption, unmarketable fruit, root development. The real deal. The results were striking. The optimal wicking bed treatment produced 3.1 kilograms of marketable tomatoes per plant. The surface irrigated treatment produced 1.8 kilograms. That is 72% more food from the same growing space. But the yield numbers were only part of the story. In the surface watered beds, nearly 17% of the tomatoes had blossom end rot, that ugly black patch on the bottom that ruins the fruit. In the wicking beds, it was less than 1%. And the wicking beds did all of this while using roughly half the water and requiring about half the number of irrigation events. So why does this work so well? And this is the part I love, because the biology behind it explains so many of the frustrations home gardeners deal with every single season. When you water a raised bed from the top, the soil moisture follows a pattern that scientists call a sawtooth curve. Right after watering, the soil is saturated. Then it starts drying out. Then it gets drier. Then you water again, and the cycle repeats. That might sound fine, but here is what is happening inside the plant during every one of those drying phases. As the soil dries, the roots detect dropping moisture levels and send a hormonal signal through the plant. A compound called abscisic acid builds up in the leaves, and when it reaches a certain concentration, it forces the stomata to close. Stomata are the microscopic pores on the leaf surface that take in carbon dioxide for photosynthesis. When they close, carbon dioxide stops flowing in. Photosynthesis slows, growth slows, fruit production slows. Every single time your raised bed dries out between waterings, even a little, your plants are hitting the brakes on their own growth. And in a typical summer, this can happen dozens of times across the season. A wicking bed eliminates that cycle entirely. The reservoir below keeps the root zone hovering right around what soil scientists call field capacity, which is the ideal moisture level where roots have access to both water and oxygen. A 2025 study published in Nature Communications confirmed that optimal plant productivity occurs almost exactly at field capacity, with an extremely tight correlation. When you keep roots in that sweet spot constantly, the stomata stay open, photosynthesis runs at full throttle, and the plant puts all of its energy into producing fruit instead of managing drought stress. And the blossom end rot issue? That is a water story too. Blossom end rot is not actually caused by a calcium deficiency in the soil. It is a calcium transport failure inside the plant. Calcium moves only through the xylem, which is the plant's water highway, and the xylem only flows when the plant is actively transpiring water through its leaves. When soil moisture fluctuates, transpiration stutters, calcium delivery to the developing fruit gets interrupted, and the cells at the blossom end collapse and turn black. The University of Connecticut Extension and the Alabama Cooperative Extension both confirm that even brief disruptions in water supply can trigger blossom end rot. A wicking bed provides such consistent moisture that the calcium transport chain simply never breaks. There is something else happening underground that matters too. In wicking beds, roots do not need to spread wide and shallow chasing surface water. Instead, they develop a denser, more efficient root mat in the zone between about 4 and 8 inches deep, right where moisture and oxygen are perfectly balanced. A separate study found that sub-irrigated plants developed 23% greater average root diameter compared to surface-watered plants. Thicker roots mean more efficient nutrient uptake, which feeds back into stronger growth and heavier harvests. If you are finding this useful, hit subscribe. I break down the science behind better gardening every week, and I have a lot more to share about how small design changes can transform your growing results. Now, here is where I want to be completely honest with you, because I think honesty is more valuable than hype. The 62 to 73% yield increase is real, and it comes from a real, peer-reviewed study. But it was a single crop, tomatoes, in a single season, in a greenhouse in Australia. Nobody has published a controlled study comparing wicking beds to surface-watered beds for peppers, leafy greens, or root vegetables. Nobody has published one conducted outdoors in variable weather. And nobody has tracked wicking bed performance over 5 or 10 years to see how the soil changes over time. What we do have, alongside the university data, is decades of practitioner experience from Australian gardeners where wicking beds are genuinely mainstream, and 14 years of documented harvest data from a gardener named Al Gracian in North America who has weighed and recorded everything. His best season from a single 4x8 wicking bed was over 100 pounds of tomatoes. Those are exceptional results from an experienced grower, but they confirm the direction of the science. There is also a real trade-off to acknowledge. Salt buildup at the soil surface is a documented issue in wicking beds because water evaporates at the top and leaves mineral deposits behind. The fix is straightforward. You flush the bed from the top with a hose once or twice a year, and rain handles it naturally in outdoor beds. It is something you need to know about going in. So, what does it actually take to build one of these? If you already have a raised bed frame, or you are building a new one, you need a pond liner, gravel, geotextile fabric, a PVC pipe, an overflow fitting, and good quality potting mix, not garden soil. This is the single most important thing I can tell you about building a wicking bed. Standard garden soil or heavy compost mixes will compact over time and destroy the capillary pore spaces that make the whole system work. You need a light, porous blend, peat or coir-based, with perlite or vermiculite mixed in. 70 to 80% base material and 20 to 30% drainage amendment. For a standard 4x8 bed, the total cost runs roughly $265 to $635, depending on your materials. That is about $135 to $315 more than a standard raised bed of the same size. Build time is 3 to 5 hours if it is your first one. If you want to test the concept before committing to a full build, the fastest entry point is cutting an IBC tote in half horizontally. Each half becomes a ready-made wicking bed for around $50. It is not the prettiest option, but it lets you see the results with your own eyes before investing in permanent beds. Now, what should you grow in them? Tomatoes are the obvious choice given the research, and they absolutely thrive. Peppers, zucchini, cucumbers, leafy greens, corn, and brassicas all do exceptionally well in the consistent moisture. Skip Mediterranean herbs like rosemary, thyme, and lavender because those plants evolved in dry, rocky soils and genuinely prefer to be a little thirsty. Garlic can also struggle with the constant moisture, so keep it in a conventional bed. Here is what fascinates me about this whole story. The principle behind wicking beds is not new. The Aztec civilization built their chinampas, those famous floating gardens near what is now Mexico City, on exactly the same concept. Soil raised just above the waterline with moisture wicking upward from the lake below. Those gardens fed one of the largest cities in the pre-Columbian world. A Florida tomato grower named Blake Wisenant built a commercial sub-irrigated planter called the Earthbox back in 1994, and it has sold over 1 million units. An Australian engineer named Colin Austin scaled the concept to full garden bed size in the early 2000s, specifically to address drought conditions. The science has been there. The history has been there. The commercial products have been there for 30 years. And yet the average raised bed gardener in North America has never heard of any of this, because the modification that actually works is invisible from the outside, while the ones that look impressive in a thumbnail have never been tested. A standard raised bed is just a box of soil. A wicking bed is an engineered growing system. And the difference between the two could be the difference between a garden that frustrates you and one that feeds you. If you want to see how this compares to other raised bed modifications I have covered, click the video on screen. If you have built a wicking bed or you are planning to try one this season, let me know in the comments. I would love to hear what you are growing.